In this video, we'll prove the triangle inequality for real numbers x and y. So the claim is as follows. If x and y are real numbers, then we have two inequalities. The first says that the absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y. And the second, which is sometimes called the reverse triangle inequality, says that the absolute value of x minus y is greater than or equal to the absolute value of the difference between absolute value of x and absolute value of y. Now, before we go ahead and prove these two inequalities, there's a couple of things that we want to note about absolute values that will be useful for us when we do our proof. So if x is a real number, then the first thing we want to note is that the absolute value of x is always greater than or equal to x. And this is pretty easy to justify. If x is a negative number, then the absolute value of x is going to be positive, and so certainly a positive number is larger than a negative number. If x was equal to 0 or was a positive number, then the absolute value of x just is equal to x, and so we recover the equality case of this inequality. But regardless of what case we are in, whether x is positive, negative, or 0, the absolute value of x is always greater than or equal to x. The second thing we want to note is that the absolute value of x squared is equal to x squared. And I think this is also quite obvious to justify. If you think about what the square function does, it turns anything that's negative into something that's positive. And so it sort of does the job of the absolute values and they become redundant. So if I have the absolute value of something squared, then I can strip away those absolute value signs and it stays as just x squared. Now I do want to reinforce that these are only true for x as a real number. If x was a complex number, these are not true. Because firstly, order has no meaning in complex numbers, so we can't really say something is larger than something else. And also this would just be false in some cases for complex numbers. Okay? All right, so now let's get into the proof. Now, in order to prove these, we're going to start with the first one, and the second one will come as a consequence of the first one. But I do want to mention that this first triangle inequality is the one that is explicitly mentioned in the HSC syllabus. And it does say to prove and use the triangle inequality and explicitly mentions this inequality. Okay, so you would be expected, it is essentially coursework for you to be able to prove this and use it in inequalities. Okay, so here's our proof. What we're going to do is we're going to start off by using this first fact that we noted up here. The absolute value of x is greater than or equal to x. So we note that for x and y both being real numbers, the absolute value of xy is going to be greater than or equal to xy. Okay, x times y is a real number, and so I've just simply applied this fact here. Now what I'm going to do is I'm going to multiply both sides of this by 2, and then I'm going to split this absolute value into the absolute value of x times the absolute value of y. And we end up at this point here. Now what I'm going to do is I'm going to strategically add something to both sides. Okay, the same thing to both sides, so we're not altering anything with the inequality. And you'll see why this becomes a very useful thing to add. I'm going to add x squared plus y squared. And you might already see why that's useful. The reason I'm adding x squared plus y squared is because I'm going to try to turn both sides into a perfect square. By adding x squared plus y squared, I've turned my left-hand side into my right-hand side into x plus y all squared. And by using this second fact, I can turn the left-hand side into the absolute value of x squared plus 2 times the absolute value of x, the absolute value of y, plus the absolute value of y squared. And this also turns this into a perfect square. So now, on my left-hand side and on my right-hand side, I really have two binomials, or two perfect squares, plus y squared. So I'm going to write them as binomials, as perfect squares. On the left-hand side, I've got the absolute value of x plus the absolute value of y all squared. And on my right-hand side, I've got x plus y all squared. Now it would be tempting at this point for me to just square root both sides to get rid of those absolute values. But that's not actually going to get me what I want. And it's actually also not correct to do so because I don't know if both sides of my inequality are going to be positive. Definitely this left-hand side is going to be positive because the absolute value of x is positive and the absolute value of y is positive. But x plus y might not be positive. So it's not safe for me to do so. Okay, because x could be negative and y could be negative. And then that would make this left-hand side negative. But what I can do is I can once again use this second fact to rewrite my right-hand side, which is something squared. But now I'm going to introduce in absolute values. So I've got the absolute value of x plus the absolute value of y, all squared, is greater than or equal to the absolute value of x plus y squared. Okay, that's simply using this fact here. And now I know that both the things inside of my squares are positive on both the left and the right hand side. Okay, just as we said, this is positive, and now I've got the absolute value of something which is definitely going to be positive. Now it's safe for me to square root both sides, and then I can say the absolute value of x plus the absolute value of y is greater than or equal to the absolute value of x plus y. And I might say since both sides are positive as a justification. And there we go. We've proven the first part of our two claims that we made. Okay, and this is I suppose this is the main one, the main result that we were interested in. Okay, how do we get the second result, which was that the absolute value of x minus y is greater than or equal to the absolute value of the difference between the absolute value of x and the absolute value of y? How does that fall out from the second or from the first inequality? All right, so what we're going to do, and I suppose this is a good exercise in a concept that we mentioned earlier, which was remapping of variables, is we're going to replace these variables x and y with some strategic choices. All right, so, and we're going to actually do this process twice. So the first time is we're going to remap x to the variable x minus y, and y is just going to stay as y. So we're not really remapping y, it's just staying as it is, but I'll write it there anyway. So really what I'm doing is I'm going to replace x with x minus y. And that's okay because x just had to be a real number and x minus y is a real number. So this triangle inequality should hold between the two real numbers x minus y and y. So let's go ahead and do that remapping. So we end up with the absolute value of x minus y plus the absolute value of y is greater than or equal to the absolute value of x minus y plus y. Of course, here we can see that negative y plus y cancels out, and I'm left with the absolute value of x on the right hand side. I'm also going to move this absolute value of y to my right hand side, and I end up with the absolute value of x minus y is greater than or equal to the absolute value of x minus the absolute value of y, which is very close to what I want to get. It's just missing one thing, which is having absolute values around that difference. Okay, so how do we end up with that absolute value around that difference? Well, we're going to do the same sort of thing. We're going to play the same game right now, but with a slightly different remapping. So what we'll do now is we'll say remap x to the variable of x. I'll just leave it as it is. Let's say and y will get remapped to the variable y minus x. Okay, so I'm going to substitute in x for x, so it stays as it is. But now I'm going to substitute y minus x everywhere I see a y. Okay, so what do we get? We get the absolute value of x plus the absolute value of y minus x is greater than or equal to the absolute value of x plus y minus x. And so here we see that x minus x cancels. My right hand side is just the absolute value of y, and I'm going to bring this absolute value of x over to this side. And so I'll get the absolute value of y minus x is greater than or equal to the absolute value of y minus the absolute value of x. And I'm just going to factor out a negative 1 from y minus x to get the absolute value of x minus y is greater than or equal to the absolute value of y minus the absolute value of x. Okay, so what I've done here, I'll just write it on the side. I've used the fact that the absolute value of y minus x equals minus 1 times x minus y, absolute value of that. Then I've broken it up into two absolute values. So the absolute value of -1 times the absolute value of x minus y. And then that gives us the absolute value of x minus y. Okay. All right, so I've got two inequalities that look really useful, which I'm going to highlight in orange. And both of them have on the left-hand side the absolute value of x minus y. But on the right-hand side, they basically differ by a factor of -1. Okay, now if they differ by a factor of -1, I can combine these two to say that the absolute value of x minus y is greater than or equal to the absolute value of their difference. Okay, and let's try to think about why that's the case. Another thing that we should, and I probably should have mentioned this at the start, but another thing that we should note about the absolute value is that it has another way that it can be defined. The absolute value of, let's say, a is our number here. The absolute value of a number a is equal to the maximum, in other words, the largest, out of this set. The set of a and minus a. And I think if you plug in a couple of numbers, you'd be able to verify that and convince yourself that that's true. So for example, the absolute value of 4 is 4. And if I have a look at this right-hand side and compute what the maximum of 4 and -4 is, well, obviously the largest of those is 4. And you can see the absolute value matches the maximum. Let's try it with a negative number. Let's say -3. The absolute value of -3 obviously is 3. And the maximum of this set, -3 and -3, is equal to 3 as well. So it's pretty obvious that it works for positive and negative numbers. And so this is another way that we can define what the absolute value of a real number is. It's just the maximum of the number or the negative of that number. Okay, so now what I can say is that, well, if we have these two results here, if the absolute value of x minus y is larger than this, and it's larger than the negative of this, which is what we have down here, then it certainly would be larger than the maximum of the absolute value of x minus the absolute value of y. So I suppose this really should have gone in this section here. Should have been a couple of lines in between this step here and our final deduction. But what we can say is that the absolute value of x minus y is larger than or equal to the maximum of the absolute value of x minus the absolute value of y. That's one thing. And the negative of the absolute value of x minus the absolute value of y. But we just saw that this is the definition or an alternate definition of what the absolute value is. And so that's how we actually get that result there. Okay, so it is a little bit involved because we need to know lots of definitions, lots of properties of the absolute value. But I think they're all simple enough to see. It's just a matter of combining them all together and putting it together in a complete proof. Okay, and so that is the end of our proof of the two triangle inequalities.